Group 6 presenting Bridge. Our group's member Muhammad Rifan Hakimi bin Rosli as the leader, Daniel Hakim bin Hashimi, Wee Jan Hui, Purosotam anak laki Vijay Tarun, and Ma Hao Chen. Contents of our presentation are included such as introduction, components, working principle of the Kelvin bridge, application of Kelvin bridge, and the conclusion. To begin with, a Kelvin bridge is used to measure the low resistance value of a system. As resistance is one of the fundamental properties of electrical and electronic system, accurate measurement is needed for optimal functioning and development of the system. Unlike other bridge systems, the Kelvin bridge provides a more accurate result, especially when dealing with low resistance value. The main principle behind the operation of the Kelvin bridge is the concept of balance, so that when the ratio of resistance is equal, the bridge is said to be balanced and no current flow through the galvanometer. This makes it easier to measure low resistance value.
Okay, so we'll continue with the components of Kelvin bridge. So the Kelvin bridge adds 2 additional resistance to the standard Whetstone bridge circuit. These extra resistance are connected in parallel to the unknown resistance and the galvanometer, creating an additional pathway for the current. So the effect of lead resistance is reduced and the accuracy of flow resistance measurements is significantly improved by doing so. So the unknown resistance Rx, the resistance value that we aim to determine. This is connected between points A and B, forming one corner of the bridge circuit. So after that, ratio arms R1 and R2. These are the resistance forming the ratio in the bridge. These are position components which are carefully chosen to ensure measurement accuracy. After that, galvanometer G. This is a sensitive device that detects the flow of current across the bridge circuit, indicating whether the bridge is balanced or unbalanced. And last but not least is the additional resistance R1 and R2. The resistance added in the Kelvin bridge to decrease the effect of lead resistance.
Hello everyone, my name is Ma Hao Chen, matrix number 223306, and now I would like to explain about the working principles of the Kelvin bridge. Okay, so the Kelvin bridge, which is also known as the Kelvin double bridge, is a specialized electrical circuit designed for accurate measurement of low resistance. It will minimize the errors introduced by the resistance of the connecting leads, allowing for precise measurements. So here are the working principles of the Kelvin bridge. So first is 4-wire measurements, which is the Kelvin bridge utilize a 4-wire measurement technique. Okay. So the second is current leads, which is the current carrying wires are designed to have a low resistance. So the third is voltage leads, which is the voltage measurement wires are thin and highly flexible. And fourth is bridge configuration, which is the Kelvin bridge is configured as a modularized Whetstone bridge. And the fifth is minimizing the lead resistance effects, which is its ability to minimize the errors caused by the lead's resistance. And lastly is measurement accuracy, which is by using the 4-wire measurement technique and minimizing the lead resistance so that the Kelvin bridge will provide highly accurate measurement of low resistance. It is particularly useful in applications such as the calibration of resistors of the characterization of conductive materials where precise resistance measurements are essential. Okay, that is the working principles of Kelvin bridge. Thank you.
Hi everyone, my name is Jian Hui and now I will explain about the application of Kelvin bridge. Kelvin bridge can be used in the linear extraction of induced voltage in giant magnetostrictive actuators GMAs with self-sensing capabilities. When it comes to self-sensing in GMAs, the traditional method using the Whetstone's bridge falls short. It introduces non-linearity and sacrifices high-frequency information, which will hindering the precision we seek. The Kelvin bridge armed with a unique capability to extract induced voltage in a linear fashion. But it doesn't stop there. Pair it with an active device, a high-precision zero-drift amplifier to revolutionize self-sensing in GMAs. This active Kelvin bridge acts as a game changer. Its powerful common mode rejection, thanks to the amplifier high input impedance compared to the GMA, eliminates non-linearity issue. With this innovative setup, we can now extract induced voltage without any distortion, preserving the integrity of high-frequency information. It is like giving GMA a crystal clear lens into their own performance. In the realm of GMA, precision is key. Thanks to the active Kelvin bridge, we are pushing the boundaries, solving non-linear problems and ensuring that self-sensing is not just a concept but a reality, with accuracy and clarity at its core.
Hi, I'm Purushottam, and I'll talk about the conclusion. A solution to the non-linear problems in the extraction of GMA self-sensing signals is presented in our application. Our application result suggests that the Kelvin bridge circuit is a more efficient source of the self-sensing signal than the conventional Wheatstone bridge. In conclusion, the Kelvin bridge is an important tool in the field of electrical measurements. This precise instrument is widely used in a variety of industries that contribute significantly to the development and maintenance of the technologies that we rely on. Let's look into some other applications of the Kelvin bridge. Like in the field of electronics, the accuracy of the way the Kelvin bridge can measure resistance is critical. While offering accurate resistance values, it guarantees the reliability of the electronic circuits, which is important for developing and producing electronic products that adhere to strict performance requirements. Another component of the society that greatly benefits from the accuracy of Kelvin bridge is telecommunications. Accurate resistance measurements are becoming more and more important as our reliance on fast data transmission increases. The Kelvin bridge minimizes signal degradation and ensures seamless connectivity as it supports the development of the complex network infrastructure. The Kelvin bridge also evolves medical technology in the healthcare field. Precision in resistance measurements is important for a variety of applications, including the production of complex medical devices and the calibration of equipment used in diagnostic procedures. To put it in simple terms, the Kelvin bridge is not just a piece of technology, rather, it is essential to the smooth operation of our technological advanced society. Its uses in research, electronics, telecommunications, and healthcare demonstrate how versatile and important it is. While we maneuver through the complexity of our everyday existence, the Kelvin bridge quietly advances the dependability and effectiveness of the technologies that define our world today.
These are our reference. Thank you for listening to our presentation.